Hello, this is Mr. Weldon, and this is Unit 3, Day 6. We're going to be learning about the distributive property today. So our content goals, we want to introduce the distributive property so we understand what that is and what it means. And we want to understand how the area model helps us to understand the distributive property. Okay? Then we're going to use that distributive property to help us simplify expressions. All right? So grab a pen, grab some paper, and remember, this is Algebra 1. All right, so we're multiplying, right? So let's review some of the multiplying stuff that we've been doing. We've seen expressions like this, and we have used our generic rectangles to multiply things like this out. So we see two things being multiplied. We have a 5, and then we have this thing inside of the parentheses x plus 3, right? So I can take that 5, and I can let it represent the height of my generic rectangle, and I can take the x plus 3. Since it has two terms, I can put the x here and the 3 over here. All right, so two terms means we need two divisions of that generic rectangle. All right, so here we go. So now when we go to multiply, we take length times the width, or height times the length, whatever you want to refer to it as. But we do 5 times x and we get 5x, right? And then we do the same thing over here. We do 5 times 3 and we get 15. And then to get the entire area of this rectangle, we add the boxes together, right? So we got 5x plus 15. Okay, so we could say 5 times x plus 3 equals 5x plus 15. All right, so these are equivalent expressions, right? And we found that using the area model. Let's do it one more time over here. We've got 3x times x plus 4, right? So we're taking 3x multiplied by x plus 4. Those are the two things that we're multiplying. There's one term in this one, so I'm going to let that represent the height. There's two terms in this one, so I'm going to put this across the top here. So we have x and 4, right? Positive 4 because it was a plus 4. Then we go through and we multiply, right? So 3x times x is 3x squared, and 3x times 4 is 12x. Then we add our two boxes together. So we get 3x squared plus, oops, I forgot an x there. 3x times 4 is 12x, right? So then I would have 3x squared plus 12x. All right, so we could say 3x times x plus 4 is equal to 3x squared plus 12x. There's my final answer for that one. All right, now I want to show you a slightly different way of doing the same thing, and that's what the distributive property is. All right, it's essentially a quicker way of handling the multiplication between two expressions, specifically when we have situations like this, like what we just did, where we have an expression that has one term times an expression that could have multiple terms. All right, so distributive property kind of works like this. It says if I'm taking 5 times x plus 3, then everything inside the parentheses has to be multiplied by 5. So it's like we're going to take 5 times x, so we're distributing the 5 to the x, and then we also have to do 5 times 3. All right, so it's like we're distributing the 5 to everything inside of the parentheses. All right, so when I do 5 times x, we get 5x, and when I do 5 times 3, we get 15. All right, so I got the same thing that I did up here when I set up my area model. It's just this is a little bit quicker because I don't have to draw the rectangle and do the individual multiplications and everything. All right, so we refer to this as the distributive property because of this this action right here, where we are essentially distributing the 5 to each term in the parentheses. Now we can do the same thing over here. We have a 3x on the outside of the parentheses here, so I'm going to distribute the 3x to each term inside of my parentheses with the x plus 4. Right, so when I do 3x times x, we get 3x squared, and when I do 3x times 4, we get 12x. Okay? And I get the same result that I did up here. All right, so that's a really quick demonstration of the distributive property. And the reason that we like this distributive property more so than the area model, at least I do, is because we might run into expressions that have more than one instance of distribution. So I have to do multiple distributions at once, and setting up area models for every time we have to multiply something like that could be time consuming. So it's just a little bit quicker. right? So when I look at an expression like this, I see these two things being multiplied here, and then I see the 5 and the x plus 3 being multiplied. And so I want to get rid of both of those parentheses in this expression. So I'm going to start over here. I'm going to take the 6 and I'm going to distribute it to the x and to the 4. Kind of like that, right? It's only 6 times the x plus 4, so I'm not going to distribute the 6 over here with the 5 and the x plus 3. That's a whole separate distribution. Over here, I'm going to distribute the 5 into the x plus 3. All right, so just do it one thing at a time, right? 6 times x is 6x. 6 times 4 is 24. And it's going to be positive, right? Because it's a positive 6 and a positive 4. And I come over here, right? So we got 5 times x, so we've got plus 5x, and then 5 times 3 is 15. Okay, so we see the results of both distributions being added together. And now what I want to look for is I want to look for like terms. Okay, so I like to grab a highlighter. Sometimes I like to look at my individual terms here. Remember, a term is anything in between a plus or a minus sign. So this is a term, this is a term, this is a term, and this is a term. All right, so we got 4 terms. And I'm going to look at this 6x. Okay, so I got 6x. It has an x that's being raised to the first power. We don't see the exponent, so we get to assume it's a 1. This one does not have an x, so that's not a like term. This one does have an x, and it's raised to the first power as well. So this is a like term. 15, not a like term. All right, I'm going to grab a different color highlighter, and I'm going to look at my other 2 terms. Right, so I got the 24. 24 is just a constant. It has no x. So does 15. 15 is also a constant. It has no x. So 15 and 24 are like terms. So now I just need to take my time and combine my like terms. Okay. So when I combine 6x and 5x, that gives me 11x's. When I combine 24 and 15, I get 39. So I have 11x plus 39. This would be my final result. I went from this mess, right, with a whole bunch of stuff, parentheses and everything else, to something much simpler and easier to work with by getting rid of the parentheses and then combining like terms. So this is what we're looking for. Okay. All right, let's mix in some negatives, right? Kick it up a notch, see if we can handle some negative stuff. All right, so here we go. We've got, it's a very much the same problem, right? It's just we have some negatives in there now. So I see here I've got negative 2 times x minus 6, right? So I'm going to take this negative 2 and I'm distributing it into the parentheses, multiplying each term in the parentheses by the negative 2. Over here I have a positive 6, and that positive 6 is going to get distributed to each term inside of the parentheses here. All right, so here I go. So I got negative 2 times x. That'll give me a negative 2x. And then negative 2 times negative 6. And this is where students start to make mistakes, right? This is a negative times a negative, so we're going to get a positive 12, right? Negative times negative equals positive. Positive times negative equals negative. Positive times positive equals positive. And that's really it, right? I mean, we could do negative times positive, but that's still a negative. All right, so you might want to write that down somewhere. It's something you should have learned back in the 7th or 8th grade. All right, so here we go. We're going to do this one now. So we got 6 times negative x, right? So that's a positive times a negative. Positive times negative is negative, right? So we're going to have negative 6x. Then I got positive 6 times negative 4, so that'll be minus 24, or negative 24. All right, so all the parentheses are cleared. Now I just got to go through and combine like terms. So I have a negative 2x and a negative 6x. I'm adding, we're not multiplying, so this no longer applies over here, right? So we're just adding these together. Negative 2x and a negative 6x combine to give us a negative 8x. Positive 12 and negative 24 combine to give us negative 12. There's our simplified result. Do not try to combine these. This one has an x, this one does not. These are not like terms. All right, now this is the one that confuses every student, all right? And I say that because of 2 different things that are happening here. First, this right here, we just have a negative sitting out front of a parentheses, and this right here where we are subtracting instead of adding in between those 2 parentheses, okay? So when we see this negative sitting outside the parentheses like that, you get to assume that's a -1. So it works just like any other number. I'm going to take -1 and I'm going to distribute it to each term inside of the parentheses. So when I do -1 times x, we get -1x. When I do -1 times -3, we get a +3. Now over here is where the students make their next most common mistake. They will distribute a 2 to the x, but forgetting that it is actually a -2. I know it says -2, but it's the same thing as -2, so you're actually distributing -2 to the x. So it's going to be -2x, and then we got to distribute that -2 to the +3. So you got -2 times +3, which is -6. All right, a lot going on with negatives there. You just got to take it one step at a time, keep them in order, and you won't make any mistakes. All right. So now combine like terms. I have a -1x and a -2x. Those are my like terms for the x's. So I'm going to combine those to get -3x. Then I have a +3. Right, I have a +3 and a -6. That'll combine to get me -3. So my final simplified result here is -3x minus 3. Do not try to combine those. Those are not like terms. All right, guys, that's it for today's lesson. Give the practice problems a try. Let us know if you have questions in the Zoom chat.